I hope you all doing great. So welcome to the EDS online multi-education platform. In today's session, we'll discuss about the real numbers. In yesterday's session, we discussed about the fundamental theorem of arithmetic. Okay. So we discuss exercise problem today. So before starting our session, let me introduce myself. I'm Uday Kiran. I'm your maths academic specialist. I'll introduce our features and tools you have. So you have chat option with you in the live session. So you can interact with me through chat, the live tutors. And in live classes, so you have expert tutors are there. In there, you can ask any doubts and clarify your doubts in the session. And also, after the class, you'll get you have recording sessions also there. Just observe the recording part and try to make your improve your subject knowledge. And you have exercise sums and all those things you'll get. Don't worry. So keep practicing, keep learning from day to day. Okay. So first of all, thanks for being here in my class. Let's get start our session. Okay.
I think the screen is visible, everyone. Yeah. Yesterday we discussed about fundamental theorem of arithmetic. In there, we solved the relation between HCF and LCM and all those things. Let's see. Let's revise all the topics. Yeah, fundamental theorem of arithmetic. So these things already we learned about the. We just write in the product of primes. What are the given number? So we just write the product of primes. How can write the product of primes? So we already discussed about some. We solved a few questions like LCM and HCF are all those number. After giving the sum, whether whatever they're asking, what we need to find first. Before that, you just do one thing. You just do one thing. So first, you just write the whatever the given number in prime factoration, like in prime numbers. After that, observe and you need to find HCF. So HF is the product of smallest power of each common factor, and LCM is nothing but product of greatest power in each prime factor. All these things we learned in the previous session. And yeah, the relation between for any two positive numbers a and b, the relation between HCF and LCM is equal to product of two numbers. Product of two numbers. These things we learned in the previous session. Yeah. And also we completed the some questions, and we completed the exercise one. Sorry, in exercise 1.2, we completed the first Roman, and second Roman we completed till second sum. Okay, let's start with the third one. Third sum. Yeah, I hope the screen is visible, everyone. Yeah, in exercise 1.2, let's start with exercise. Exercise 1.2. Here we just start the second question, third one. Second question, third one. Okay, what is the question they given? Uh, yeah, you just find the LCM and HCF of these two numbers. First, write the numbers here. What are the numbers they given? The two numbers. Let's change it. Yeah, the two numbers they given 336 and 54. You can take A is equal to 336, the first number, and B is equal to 54. 54. Okay. Without solving all those things, first you just write in the prime factors. Let's write the prime factors for 336. Yeah. So if you take that, okay, it is in the form of, you can take the 3 table, 3, 1, 1, 1, 1, 2, and 1, 1, 2. So you can take that in 2 table, you can write 3 into 1, 1, 2, you can write like 2 into 5, 656. And 3 into 2 into 56, you can write like 2 into 2, 8. So 3 into 2 into 2 into 28, we can write it as 2 into 1, 4. And 3 into 2 into 2 into 2 into 14, we can write it as 2 sevens are. We just stop it here. Okay, why? Because here all we got, 2, 3, 7, we can't split further. So we all are prime factors. So that's why we just stop it here. And let's write the common factors here. Here, how many twos are there? 1, 2, 3, 4, 2 power 4, 3's, 3 power 1. Is if nothing else, you can take 7 power 1 like this. Okay. Yeah, now let's write the factors for 54. 54 we can write it as 2 into, in 2 table, it is 2 into 17. Okay, I'm writing 2 2s once again. Yeah, 2 into 27. 27 we can write it as 3 9s are, and 2 into 3 we can write it as 3 into 3. Now you will get like yeah, you'll get 2 power 1 into 3 cube. Now observe carefully. Now you need to find a HCF. HCF, let's find the HCF here. HCF is nothing but you just take the common numbers. Here 1 2 and 1 2 is common. Let's write 1 2 here, and yeah, 1 3 and 1 3 is common. Let's write 1 3, and anything else here 2 2 2, no nothing, no 2, and 7, no 7, no 3. Okay, so HCF you can take it as you'll get 6. You'll get 6. Now how to find LCM? LCM, let's do it here. LCM, you can take the highest greatest power. Greatest power in terms of 2. So greatest power would be 2 power 4. Greatest power is 2 power 4. Why? Because here 2 power 1, here 2 power 4. Which one is greater? 2 power 4. 2 power 4. That's why we are taking 2 power 4 here. And in terms of 3, 3 power 1, 3 cube. Which one is greater? 3 cube. That's why you can take 3 cube. And any other numbers is there? 7 is there. So 7, only 7 power 1 is there. So that's why you can take 7 power 1. 2 power 4 is nothing but 2 into 2 into 2 into 2. Okay, so you'll get 2 to the 4, 4 to the 8, 8 to the 16. 3 cube is nothing but 27, 27 into 7. Yeah, after multiplying all these values, the LCM we got, yeah, 3 into, 16 into, so let's do it here. Yeah, so I got 3024. So we can save our time. 3024. Okay, so let's see. Okay, but what is the question here? The question here is, after getting LCM and HCF, you need to do one thing. So you just verify. Verify what we need to verify. Let's write it here. What we need to verify. Where we started here. Yeah, verify. We just do the verification. Whether it is, I mean, LHS, RHS, or we are getting correct or not. Let's write it here. Yeah, what is the formula? LCM into HCF is equal to product of two numbers. What are the two numbers? A into B. The two numbers would be A into B. Okay, LCM I got 3024 here, and HCF, what are the HCF we get? 6. HCF we got 6 here. That's why we just multiply 6. And product of two numbers, what are the two numbers initially we taken? AB, 336 and 54. 336 into 54. Okay, do the calculation. So 4 6 are 20, 4 6 are 24, 12, 14, and 18. 18144 I get. 18144 in LHS part. Same way, if you do the same thing, you just multiply on your own. Let's see what are the value you'll get. So 1316, so 336 and 54, 50 into the 300, so it is 1800, 1800 36, 36 into 53, 1500. Okay, 1800 plus another 1500. Okay, so the same value I got, 18144. So we'll write it as LHS is equal to RHS, and we prove that both are equal to each other. Okay, so we just verify like this. So that is the question. I hope everyone understood. I'll explain once again. Understand carefully, guys. So first, in the question, the given the two numbers 336 and 54. Okay, you can do like 336 and 54. So you can take the numbers first. You just write the prime factors. So these are the prime factors for 336 and 54. HCF, you can find HCF by taking only common numbers. But while LCM, you don't need to follow that. So HCF here 3 and 2 only the common thing. So that's why we just multiply 2 into 3, you'll get 6. And LCM, you can take only the highest power, greatest power. 2 power 4, 3 cube, and 7 power 1. You get 3024. But the question is not completed. We need to verify. Verify with the formula LCM into HCF is equal to product of two numbers. So this is what we learn. So we'll get 18114 it is both are equal to LH is equal to RHS. Okay. Okay, let's move on to the next question. What is the next question? Find the LCM and HCF of the pair of integers. Okay, find the LCM and pair of integers by applying prime factorization method. Okay, let's do by prime factorization method. First, write the question first. Third Roman, first one, right? Okay, what is the question? 12, 15, 21. 12, 15, 21. Okay, whatever the question, first do one thing, you just write in terms of prime numbers. Okay, write the prime factors for 12. So if you write once again, yeah, if you write prime factors for 12, so we'll get, once again guys, okay, now it's working. Okay, prime factors for 12, so 2 times 6, 2 times 6, so 2 into 6, we can write 2 into 2 into 3. Finally we can confirm 2 square into 3 power 1. Okay, similarly for 15, you can write 3 into 3 into 5. Okay, 3 into 5, that's it. So we just write only 3 into 5. That's why 3 power 1 into 5 power 1. For 21, you can write like 3 sevens are, that's it. 3 and 7 are both are prime numbers. So you can write 3 into 7, 1. Okay, what is our job? So find LCM and HCF. What we need to find LCM, sorry, first we'll find HCF. HCF is nothing but you can take the common numbers. Let's see in the 3 numbers you can consider. So here, yeah, I think 3 is the only common for all. Here 5 is there. Here 5 is not there. Here also 5 is not there. Here 7 is there. But in the other 2 numbers, 7 is not there. That's why we can confirm. We can confirm it. HCF of 12, 15, 21. It is 3. Now similar way, find LCM of 12, 15, 21. The 3 numbers they asked for. 3 numbers they're asking for. One second, guys. Yeah, 12, 15, and 21 they're asking for. So do one thing. So here you just take the greatest power. What is the greatest power here? For 2, in case of 2, what is the greatest power? 2 square, and 3 power 1 is the greatest power, and 5 power 1 and 7 power 1. You can take all the numbers, guys, without only not only taking the common factor. You can take all the numbers. Okay, 2 square is nothing but 4. 4 into 3 into 5 into 7. Okay, so 4 3s are 12. 12 into 5 7s are 35. So you will get like 12 into 35. You will get 420. You'll get 420. All right. 12 3 is 360. 360. 12 5 is 60. 360 plus 60, you'll get 420. Yes. Okay, so this is how you just find the LCM and HCF for 3 numbers. So nothing else. They asked for prime factorization method only. We no need to verify whether it is correct or not. Okay. Yeah, I hope you understand how to solve. Yeah, let's solve the next question. 7, 23, 29. Third question, right? Yeah, third one, second Roman. Second one, what are the numbers? 17, 23, 17, 23, 29. Okay, where we are, we moved, yeah, 17, 23, 29. Yeah, let's write it here. Okay, so for 17, so 17 is also a prime number, so that's why we can write only 17 also a prime number. We just write like this. So 17 into 1 only. 23, for 23 it is also a prime number, that's why we can write 23 into 1. 29 also a prime number, 29 to 1. Why? Because we can it is not divided with 2 and 3 and all those numbers, so that's why we can write directly like this. Okay, 17 to 1. Now, finding HCF is a difficult task. Why? Because HCF of 17, 23, 29. We can't take what we don't know what we need to take. I'm sorry. We don't know what we need to take common. Observe carefully, guys. Here, what is common from both? 17, it is not there in other two number. 23, it is not there in other two numbers. 29, it is not there in 17, 23. Only common number would be 1. Quite interesting, right? So only common number is 1. So that's why we can mark it as 1. I hope everyone understood. But well, when it comes to LCM, so we can't take 1. Why? Because we can take the greatest power. So 17, 23, 29. So we just write all the numbers. Why? Because first 1 is common for both, and 17 power 1 and 23 power 1, 29 power 1. If you multiply all the numbers, so you'll get, I'm writing the value directly, 11339. Okay. So just multiply 17, 23, 29, you'll get the same value. I hope you understand. Simple, guys. In exams, if you couldn't get that, if you couldn't get what we need to take common from 17, 23, 29, so just write like this. So 1 is a invisible common factor for all the numbers. I hope you understand. 1 is the invisible. That's why you can take 1 as the common factor. Let's move on to the next question. Now 8, 9, 25. 8, 9, 25. Okay, third Raman, third question. 8, 9, 25. You just write 8 here for 8 and 9, 25. You just write the factors, prime factors. Let's write it here for 8. That is 2 into 2 into 2 and 1. 1 is, I said, 1 is the invisible common factor. For 9, you can write 3 into 3 into 1. 5. So you can write 5 into 5 into 1. Now finding HCF of 8, 9, 25. All right. So HCF here, what is the common here? 1 is the common. Okay, 1 if whether we are taking or not, it's not a big issue. And any other things factor here, all are 2's, but 9 and 25 there is no 2's. Here 2 3's are there, but here nothing 3 is there. Okay, so again the same question will got HCF is equal to 1. Interesting, right? Yeah. So similarly, find LCM of 8, 9, 25. In this particular type of questions, so you just take the highest power. Okay, so I didn't write anything here. 2 cube into 1. Here 3 square into 1. 5 square into 1. Now write the factors. I mean, first 1, and for 2, only 2 cube is the greatest power. For 3, yeah, only 3 square is the greatest power. For 5, it is the 5 square is the greatest power. Okay, 1 into, okay, 1, we ignore the 1. 2 cube is nothing but 8. 8 into 9 into the same question. We just multiply the same question again. So 8 into 9 into 25, you'll get 1800 is the LCM. Okay. I hope you understand how to solve this. Yeah, you just need to find the LCM HCF. That's it, guys. Okay, let's move on to the next question. Yeah, our next question would be fourth one. Quite interesting question. Pay attention, everyone. Yeah, fourth question. Given that HCF and HCF of two numbers is here 306, 657 is 9 they given. So first we'll write, we'll identify what is the HCF of, why should we write all those things? We'll do one thing. So what are the first two numbers? Two numbers in the given. Observe carefully in the bracket of HCF they given 306, 657. So that are those are the two numbers. You can identify like this, 306 and 657. All right. And in the question, they given HCF value. HCF value already they given 9. No need to find again. So they given already 9. And LCM we don't know. So we need to find. That is the actual question. I just give you a few seconds. Observe carefully what are the question they given. Understand carefully. Why? Because the after giving 306 and 657, don't need to write all the prime factors. Okay, and you can save your time by observing the question carefully. All right. Yeah, let's find LCM. Here in the four factors, I mean, we know three variables are known, A and B HCF, and we need to find LCM. What is the formula? We know. So we know the formula of LCM into HCF is equal to product of A into B. I mean product of two numbers. Okay. Let's substitute here. LCM we need to find once again. Yeah, LCM we need to find. HCF already in the question they given 9. Product of two numbers is nothing but 306 into 657. We need to find LCM. So we just transfer 9 to other side. It becomes 657 by 9. Okay. Any cancellations here, guys? Let's do the calculation. 9 times. Yeah, 9 3s are 27 and 9 4s are 36. Okay, we simplified like 34 into 657. 34 into 657. After multiplying this, you'll get 22338. 22338. So I'm writing, we have to save the time. So that's why I'm writing final answer 22338. I got. I hope you understand. Yeah, so no need to find, no need to write all the prime factors. Why? Because already HCF value indirectly they given 9. HCF is equal to 9, they given. Okay. So that's why you can take HCF is equal to 9. All right. Still have any doubts, anyone? Okay, let's move on to the next question. Yeah, fifth one, check whether 6 power n can end with the digit 0 for any natural number n. Let's do it here. Fifth question. Okay. 6 power n can end with a digit 8. Okay, first you need to know the divisibility of 0. So what is the divisibility of 5? Divisibility of 5. How many of you know the divisibility rules? Divisibility rule of 5. So divisibility rule of 5 is nothing but, so it would be the number ended with 0, 0 or 5. 0 or 5. So that is the thing we know. All right. So here 6 power n, how can you write 6 power n in the question they given? 6 power n in prime factor, how can we write? 2 into 3 power n. 2 into 3 power n. If you take some random values of n is equal to 1, 2, 3, so on. So if you substitute carefully, so you'll get 6 power 1, 6 power 1, 6 square, and 6 cube, 6 power 4. 6 is nothing but 6. 6 square is nothing but 12, 18, and I'm sorry, we are multiplying, I'm sorry. 6 square is nothing but 36. And here, if you multiply 6 into 6 cube, 6 into 6 into 6, so you'll get 216. And 6 into 6, so you'll get 1296. So observe carefully here, the digits are ended with 6 like this. But in the question they asked for, it would be ended with the digit 0. It would be ended with the digit 0. But nowhere else we are seeing digit ended with 0. So the digit ended with 0, it is a divisible rule of, 1 second guys. Ignore the noise once again. Okay, so the ending digits, it's ending with 6. That's why. So that's why we can say that we can simply say that the divisible rule of 0 and 5, but it is ending with 6. That's why we can confirm that it is clearly that if you take any natural number n is equal to 1, 2, 3 till so on infinite, till infinite, so you will get the ending digit would be 6, or I mean the divisibility of 6, but you couldn't get 0 or 5. But here they asked for the digit ended with 0. That is not possible. That's why you can write like this. It is clearly that, so 6 power n not divisible by 5. Okay, you just write like this. You can show the example like this. So you can take some natural numbers n is equal to 1, 2, 3, so on, and you can substitute over there. You'll get like this. Okay. I hope everyone clear. Yeah, let's move on to the sixth question. Sixth question, explain 7 into 11 into 13 per 13 plus 13 and 7 into 6 into 5 into 13 plus are composite number. Okay, before that, so you need to know the composite number. The composite numbers are nothing but, so the by the definition of the composite number, so a number, so is a composite number, it means that it factors other than, yeah, other than, once again, other than 1, the factors are other than 1 and itself. We called as composite numbers. Composite numbers. Okay. Here in the question, they given like 7 into, okay, let's write the question first. 7 into 11 into 13 plus 13. All right. So if you take 13 as common from both, I mean, we can put the bracket for this. If you taken 13 as common, so what you'll get? 7 into 11 plus 1. But because you are taking 13 as common. All right. So now 13 into common. Yeah, after taking 13 as common, so you'll get 13 into 7 into 11, 77. 77 plus, you'll get 1 here. So 13 into 17 plus 77 plus 1, you'll get 78. 13 into 78, you'll get the factors like this. I mean, it is not, it's a composite number. So that's why you can confirm as the other than factors 1 and itself. Other than factors for 1 itself. So that's why the given number is composite number. Let's write the another number. What is the question they given? Okay, let's do it on the next slide. 7 into 6 into 5 into 4 into, okay, so they are decreasing order, they're writing 7 into 6 into 5 into 4 into 3 into 2 into 1. They given 5, right? Yeah, they given 5, right? You just put bar like this. If you put bar, I mean, all this is the one data. Okay, all the multiplication here. So take 5 as common. Why? Because here 5 is there. So you just take 5 as common, and what you'll get, you can remove the 5. So you'll get 7 into 6 into 4 into 3 into 2 into 1. Plus already 5 as you taken as common. So you left with 1. So 5 into 7 into 6 into all those things after multiplication. 3 to the 6, 6 for the 24, 24 into 6 and 74. So you'll get 1008 plus 1. Okay, so 5 into 1009. Okay, after multiplication, 5 into 1009. So you'll get like, yeah, once again. So you can say that, so what is the composite number? We discussed about factors other than 1 and itself. So we're getting the numbers like this other than 1 itself. So that's why the two numbers, whatever they given, are composite number. What they asked in the question, explain why. So these are the composite, they are composite numbers or not. Okay, you just explain by applying the process. Why? Because we are taking common. We are taking common. Which question? Yeah, this one. We are taking 13 as common here. 13 as common here. So you'll get like this. All right. Yeah, let's move on. That is your, yeah, you can write like this. So the two numbers given here are, the two number given are composite numbers. You can confirm this is the composite numbers. I hope you understand. Okay, let's move on to the last question, I think. Yeah. Last question. There is a circular path of around a sports field. Sona takes 80 minutes to drive one field and Ravi takes 12 minutes for the same. Suppose they both started at the same point. Okay, so do one thing. Yeah, we'll take the one park here, like a park. Observe carefully what the circular path around a sports field. Sonia take 80 minutes to drive one round. Okay. So here Sonia will take the Sonia here. Sonia, she take 18 minute or 18, yeah, 18 minutes. 18 minutes. And who was the other person? Ravi. Ravi, he take 12 minutes. Okay. So this is a circular park. They just started here. Let's suppose they just started here. Sonia and Ravi. Okay. Both are started here. So after completing a once complete circle, so they come here, they comes here, they just stop it here again. After path around the sports field. So while taking the suppose they were started at the same point. They started the same point at the same time and going the same direction after how many minutes? So after how many minutes they will meet again at the starting point. So after how many minutes they are again meet at the same point. In that particular case, what we need to take? How to solve this one? Think about it. How to solve this? So here we can't take HCF. I mean, we already learned about HCF and LCM. HCF is nothing but highest common factor we have to take. LCM is nothing but least common multiple. I mean, here we have to take the greatest power. So both are started at the same point and same point and same time. Okay. So Ravi, he take 12 minutes. So Ravi complete the task first completely, but Sonia completed after that. So this is the thing we already know that. Okay. So in that case, you can take the LCM of so they are meeting at the same point. So LCM of you can take you can take LCM of 12 comma 18. 12 comma 18. So before taking the LCM, you just need to write the factors for 12. So 12 factors are 2 into 6, 2 into 2 into 3. So that's why 2 cube into 3 power 1. And for 18, that is 2 into 9, 2 into 3 into 3. So we can simply write it as 2 into 2 power 1 into 3 square. All right. So LCM is nothing but we can take highest common greatest power. So here in terms of 2 square and 2 power 1 is there. So you can take only 2 square, the greatest power. 3 power 1, 3 square. So you can take only greatest power. 2 square is nothing but 4, 3 square is nothing but 9. So after 36 minutes, okay, after 36 minutes, they meet at same point. After 36 minutes, they meet at same point. They meet again. I hope you understand how to solve this. All right. Yeah. So here the question asked like they started at the same point and same time in same direction also. So that's why we drawn that like we taken that same direction. So here is the same direction. Yeah. So same direction and at the same point. My pen is not working. Once again. Yeah, same direction. And they started at the same point. You can take like this. So in that particular case, so they ask like this, you just take the LCM. But because we have to take the greatest part. So he completed one round and also Sonia also completed one round. And for 36 minutes after is nothing but, so how many, I mean, generally I'm asking that after 36 minutes, they meet again. Okay. So Ravi taking 12 minutes. I mean, asking for general questions. Ravi taking 12 minutes. So 36 minutes, how many rounds he completed? Okay. Let's do like this. Let's write like this for your understanding. For one round, Ravi takes 12 minutes. For 36 minutes, I mean, they are meeting at the same time at 36 minutes. And how many rounds Ravi completed? So in that case, you can do like x is equal to 36 by 12. So he completed 3 rounds. He completed 3 rounds. While coming to who is the next person? Yeah, Sonia. Sonia completed. If they ask the cross question like this in exam, Sonia one round completed in 18 minutes, I think 18 minutes. So how many rounds she completed? In 36 minutes. Why? Because they are meeting at the same point at 36 minutes. That's why I'm stressing this. Now x is equal to 18 by 36 by 2. 36 by 18, I'm sorry, 18 2 sir. So she completed 2 rounds. Okay, so she started it slow. I mean, she's taking more time compared to Ravi. That's why she completed only 2 rounds, and Ravi completed 3 rounds in this gap. Okay, after 2 rounds and 3 rounds, so they meet at 36 minutes. Okay, I hope you understand. All right. So till now, so we completed the exercise 1.2 and we completed all the question. Still have any doubts? So try to revise all the topics and try to see the recording session. Okay, I mean the video again. Next topic would be revisiting the irrational number. Previously, we already discussed about the irrational number in the previous classes. Now we'll see how to solve. I mean, how irrational number we cannot we write in the form of p by q form. In the 9th class, we learned about how can we write irrational number in the form of p by q form. But now we have to discuss the general statement of that. How can we write in terms of how can you cannot be write in the form of p by q. Okay. Yeah, this topic we'll solve it later. I mean the next session. Okay. Yeah, so we have a lot of examples also there. Yeah, and there are other topics also there. Revisiting rational number and decimal expansion. These all those things, irrational number, decimal expansion, all those things you already completed in the ninth grade. All right. Yeah. So I hope session is informative. All right. Yeah. So this is a easy. It's not a. It is an easy subject, right? So in exam, generally from exercise 1.2, they're asking a lot of questions in exercise 1.2. Why? Because finding HCF and LCM, they're given like 1 mark question, 2 mark question in your main exam. So plan accordingly and practice more question in your textbook and also example questions. Okay. Yeah. I just end up here, guys. Okay. So anything we left? Yeah. So I just end up here. Yeah. Thanks for being here in my class and try to revise all the topics. Next class, I'll ask you a few questions about that, what we learned in the previous session. In that time, you need not to be in blank phase. You should be aware of some knowledge about the what we discussed in the previous class. Okay, try to revise all those things and keep learning, keep safe at your home. Okay. Yeah, bye bye everyone. Have a good day.